So I wanted to take some time to go through that opener and give you actual lessons. And if you could please take notes of this so that you can use these notes to help you out with the problems and the practice. So again, from the opener you saw you had a tug of war with two people, and each of those people put a force of 10 newtons onto the rope. And we're going to actually start working on force diagrams that look a little bit different than what you've been used to. So example one was a two-person tug of war. And in this case, we have the rope being the reference point. There is a force of gravity, so it's not necessarily a large force. And there is a normal force, and you might ask, what's the normal force? The normal force is that the rope is lying on your hand, which is a surface, before you pull it. And what's different about this tug of war is we're going to look at force diagrams a little bit differently, is that you have an applied force over here. That's one person, that's applied. You have an applied force over here. That's one person pulling, and another person is pulling on the other side, so you have a second applied force. So in this case, in the tug of war, you have not frictional force, but instead two applied forces. And in our example, we said that each of those people pulled 10 newtons, okay? So if you looked at what force that is, you can look at it as a total force. And in that case, you have 10 newtons being pulled here, 10 being pulled here. That's a total force of 20 newtons. But if you were to look at it as a net force is sort of like, well, what is the overall force that this is experiencing in one certain direction? And the answer is 0, because it's being pulled equally from one way as it is in the next way. So this one here is actually, if you noticed, it's a balanced force diagram. Now, you might say, oh, but these two vectors, the normal vector and the gravitational vector, they're shorter than the FA vectors, and that's true. But because the FN vector is of equal magnitude to the FG vector, those cancel out. And because these FA vectors are of equal magnitude, those cancel out. So you have a net force of 0. Okay, and this is considered balanced, and it follows Newton's first law because it is balanced. Remember, Newton's first law only has balanced force diagrams. So let's take a look at example number 2. In example number 2, you have a 4-person tug of war. Okay, so in this case, we're going to draw a force diagram, but it's going to be a little bit different. So again, we have our normal force from the rope lying on our hand. We have gravitational force, and now take a look at this. I have one person who is pulling 10 newtons, and I have a second person pulling net 10 newtons, and this should be exactly the same length because there are two people on one side. On the other side, I again have two people, so this is my FA, and each of them are pulling 10 newtons. So I have a force diagram that kind of looks like this, but how would that look like? How do we want to make that look like on a regular force diagram? So we would actually get our FN again, our FG. And because these forces are being added together, I would actually draw a force diagram that looks like this. So there's things that are a little bit different that I want to point out. Oops, that should be a straight line. Let me erase that. Okay, so this is 10 newtons, and this is 10 newtons. And this is your FA and your FA. So now why these two vectors. Well, this is the first person who is pulling, and this is then the second person. And so they have additive forces. You can look at it this way. And so why is it that we want to have these two arrows? Because for the person who's looking at this force diagram, they realize that two forces were involved pulling one direction and two forces were involved here. If we just drew one long vector, it would look like it's only one person that is adding all that force. And in this case, our total, though, this time, is no longer 20, but we have to add all of our numbers. And we're going to ignore the normal and the gravitational force. We'll just look at the applied force. So 10, 20, 30, 40. So we have 40 newtons. Okay, what is our net force? Meaning, is there one force clearly more in one direction? The answer is no. So the net force is 0 newtons again. All right, does this look balanced? And you take a look and you say, okay, gravitational force vector looks about the same length as the normal force vector, so those are balanced. And these applied forces pointing in this direction should be the same as the applied forces on this one, so those are equal as well. This is considered balanced and therefore follows Newton's first law. All right, let's do the last one. The last one is example 3. In this case, you have a 5-person tug of war. All right, so in that case, again, we do a force diagram, just like we did before. We have Fg, we have Fn. All right, in this case, we have maybe 3 people pulling on this side. They're all pulling at 10 newtons, 10 newtons, 10 newtons. And in this case, because it's a 5-person tug of war, only 2 people are pulling on this side, and they're pulling each 10 newtons. Okay. So now with that, how would the total force diagram look? Remember, because you have 5 different forces being applied on there, you need to show that graphically with a force diagram. So in that case, I would draw 3 arrows. The reason I'm drawing 3 arrows is because I have 3 applied forces. You can look at it as 3 people pulling here. And each of them is pulling 10 newtons. And 2 people pulling here. And they're all pulling 10 newtons as well. And remember, these are applied forces. So in this case, your total force is 50 newtons, and your net force is that you have 10 newtons, and I will say as a net force, meaning that there is 10 more on one side as there are on the other. These are not balanced, and because they're not balanced, they don't follow Newton's first law. So you're going to have problems that I want you to work through and see if you can create force diagrams that look like this and identify whether or not they're balanced or not balanced, okay? And we will go through those in class. Have a wonderful Halloween, and I will see you next week.